Hey guys, welcome to another video for pre-calculus. In this video we're working out problems from 5.4 where we're using sum and difference identities. So what sum and difference identities helps us to do is that when we have problems that when they ask us to find the exact values for cosine 75 degrees, if you look at the unit circle, we don't have an exact value for the cosine of 75 degrees. But with sum and difference identities, what we can do is we can break up cosine into constituent parts that sum up to 75 degrees. For example, cosine is 75. I can look at my unit circle and I can identify that I have exact values for 45 degrees and 30 degrees, which sum up to be 75 degrees. And since I have this, I've broken this problem up in such a way, I can use the sum identity of cosine, which is cosine A times cosine B minus sine A times sine B. And so let me break this up for you and show you how it actually looks once I start working it out. So again, I'm using the sum of cosine. So that means cosine of A, which is angle A, which is 45 degrees. So here, this is my angle A and this is my angle B right there, times the cosine of B, which is cosine of 30 degrees, minus the sine of 45 degrees times the sine of 30 degrees. So now what I can do is I can go to my unit circle and I can look for the exact values of these specific terms. So at 45 degrees, the cosine at 45 degrees is square root of 2 over 2, and at 30 degrees the cosine is square root of 3 over 2 minus the sine of 45, which is square root of 2 over 2, times the sine at 30, which is 1/2. So now at this point I can just do simple arithmetic. This is the square root of 6 over 4 minus the square root of 2 over 4. Simplified is square root of 6 minus square root of 2 all over 4. And that's my answer for number 1. So let's work out another problem, number 3, where you're using sine this time. So now, not only are you using sine, but you're also using radians. So sine of 11 pi over 12. Now radians is a little bit more difficult because, perhaps maybe you have angles that are more memorized, but it still works the same way. So for example, I have sine of 11 pi, and I want to break this up into its constituent parts. So I know that my denominator will be 12, and I'll have pi on both. So I want to find two terms that will add up to 11. So for example, I can have 8 and 3. Now 8 pi over 12 is not a common radian that I have, but if I'm crafty, I can simplify this. Sine of 8 pi over 12 can simplify to, let's see here, I can simplify to 2 pi over 3, because I divided I divided both numerator and denominator by 4, and then my 3 over 12 can simplify to pi over 4. And those radians I do have, right? I mean, I had the other ones too, but these simplified versions make it more obvious as to where I can locate these. So now all I have to do, and since I have sine and I'm doing the sum, I'm doing now the sum of sine identity. So that's going to look like sine of A, which is sine of 2 pi over 3, times the cosine of B, which is pi over 4, and then it's going to be plus the cosine of A over 3 times the sine of pi over 4. So now I'm going to go to 2 pi over 3, and I'm looking for the sine, which is square root of 3 over 2, and then I'm going to pi over 4, and I'm looking for the cosine, which is square root of 2 over 2, and plus the cosine of 2 pi over 3, which is minus 1/2, times the sine of pi over 4, which is square root of 2 over 2. And just like the previous problem, at this point I just do my arithmetic. Square root of 6 over 4 minus square root of 2 over 4, which gives me square root of 6 minus square root of 2 all over 4. And that is my simplified, that's my simplified answer to number 3. All right, so I'm jumping over now to number 5, and I'm working out a tangent problem now. So as you can see, I will be using the sum or difference identities of tangent, and those are a little bit more involved. And I have tangent 23 pi over 12, and I want to break that up into two constituent parts, and I'm going to use sum again. And I know I'm going to be denominator 12 and both pi. So I want to find out two terms that will give me 23. So let me see if I do 14 and 9. That'll give me 23, right? So I can simplify these terms. I can simplify it to tangent, divide both by 2, I get 7 pi over 6. And divide this by the second term by 3, I get 3 pi over 4. And yes, these are much more recognizable radians that I can use. So, and remember, tangent is sine over cosine. So I want to do the sine divided by cosine, or sine multiplied by the reciprocal of cosine to get what the value of that particular radian is. So I'm using the sum of tangent. So that means I'm going to have tangent of A, which is 7 pi over 6, plus the tangent of B, which is tangent 3 pi over 4. So pay attention to the left side there. I have it squared, the one that I'm going to use, and I am writing it out at the bottom. So that's going to be 1 minus tangent A again, 7 pi over 6, times tangent of 3 pi over 4. So now I'm going to go to my unit circle, and I'm going to find the unit for the tangent of that 7 pi over 6. Okay, so let's look for the exact values of these. So tangent 7 pi over 6, that value is going to be square root of 3 over 3, plus tangent of 3 pi over 4 is going to be negative 1. Right? So let me highlight what the terms correspond to. So tangent, that's the value of those tangents there. So it's going to make it easier for myself, and that will make it easier for myself in the denominator, because now it's minus, and I know what the value is there of tangent 7 pi over 6, which is square root of 3 over 3 times a negative 1. Okay, so now what I'm going to do, I have this simplified here. Let me work out what the numerator is going to be. So I want to break this up into just simple parts, because this looks a little overwhelming perhaps. So let me just break it up into simpler parts. Square root of 3 over 3 plus a negative 1. So to make this easier, I can make negative 1 into a fraction, and it's going to be negative 1, so I can just go ahead and say minus whatever that is. And I want to go ahead and make it into a term that has the same denominator. So simplified, this will be square root of 3 minus 3 over 3 divided by whatever I end up getting for my denominator. So let's work the denominator out now. So I have square root of 3 over 3 times a negative 1, so that's just going to be a minus, right? And a minus is a plus, so I am going to have 1 plus square root of 3 over 3. And I'm going to do the same thing I did in the numerator. I'm just going to make this into 3 plus square root of 3 over 3, which will give me 3 plus square root of 3 over 3. Oops. So I have 3 plus square root of 3 over 3. Now, since I have two fractions, I have a fraction, and my numerator and my denominator are both fractions, I want to move my denominator into the numerator position, so then I will multiply it by its reciprocal. So I'm going to end up with square root of 3 minus 3 over 3, which is my numerator, multiplied by the reciprocal of my denominator, which is 3 over 3 plus square root of 3. Cancels. So I end up with square root of 3 minus 3 over 3 plus square root of 3. I'm not quite done yet because I have a radical in my denominator. I want to get rid of that. And I don't know if you recall from last year, one of the easiest ways to get rid of a radical that is in a term with a plus sign, I can multiply it by its conjugate, which will be, in this case, it'll be 3 minus the square root of 3. So 3 minus square root of 3. And again, I'm multiplying it by 1, right? This is still 1, but it's the conjugate of the denominator, so it'll simplify my problem in the end. So, excuse me, let me go ahead and work out the denominator first. I can work out the numerator first if I want, but I'm just going to go ahead and do the denominator first. Did I say the denominator? I guess I could work out the numerator first, but I'm going to just do the denominator first, just because I want to, I guess. All right. Well, I guess because this is the reason why I'm doing the conjugate in the first place, is to get rid of that radical. That's why I'm doing the denominator first. So we're going to disperse each term here. Now at this point I'm just foiling, so this goes back to algebra 1, pre-algebra, so feel free to fast forward, or just, you can listen into the whole process if you wish to. So this is 9 minus 3 square root of 3, and then of course I distribute this term. That gives me plus 3 square root of 3 minus a 3. So yes, that I've succeeded in getting rid of this. So that gives me 9 minus 3, that's 6. So then my denominator is 6. All right, excellent. So now I'm going to FOIL my numerator. That is square root of 3 minus 3 times 3 minus square root of 3. So 3 square root of 3 minus 3, negative 9 plus 3 square root of 3. So I have a like term. It's going to be 6 square root of 3 minus 12. So I notice here that I can factor out a 6 from here. So I'm going to factor out the 6 over square root of 3 minus 2. Okay, so now I'm going to put that in my denominator, 6 times square root of 3 minus 2, and I'm glad I factored out that 6 because check that out. Boom. Those cancel out, leaving me with square root of 3 minus 2. And this is my final answer for number 5. How exciting is that? All right, great. So I only did 1, 3, and 5, but we'll work some more problems out in class. So good luck in your studying.